Now once we are done with this, you can see the right tick on this geometry, but still a yellow sign in mesh. What you can do, you can right click on it, you can update. Okay, once you do this update, you will see the right tick message over here and the show message as well. Anything is there? No. Okay, uh, if you click on this and click on update, again you can see what any message you are getting. No. Okay, so there is some message you can see. You may see that 4 messages are there. Yeah, this message is important. The mesh translation to Fluent was successful. Once you do this, then it is okay. Now in this Fluent, first of all, save your project. Then double click on it. Once you double click on it, this window will open. You have to click on double precision. Since you are using the ANSYS 25 student version, so you maximum you can select the this 4. What is solver processor? If you will open your task manager, you can see the performance in the performance tab. You can see this disk or size memory. Yeah, memory. If you right click on it, view CPU. Okay, so in my system there are 8 cores and 16 logical processor. So there are total 16, 4 4 4 4 16. So you should check your system, how much logical processors are there in your system. That maximum number you can select over here. I can select maximum. I can select 2050 also, but allowable is 16. But since you are using ANSYS 25 student version, you can select maximum 4 only. Okay, if you're using some crack version, you can select maximum. Even if you select 100, does not matter. The maximum it will work for 16. Okay, according to your PC capacity. Then click on start. Allow everything. So it's, again I told you that I'm using dark mode, that's why the theme is dark. You can select any other type of theme as well. It is opening, just wait. Okay, so here you can see I guess it is loaded, perfectly loaded. I can see here also there's nothing written over here. So this is the domain, and this is actually Fluent window. Okay, so you can see by default it is showing some inlet and outlet, it is showing mesh. Okay, so there are multiple tabs you have to go through. First of all, by default it is in steady. Okay, sorry, it is in general. You can see the general. So you can say click on scale, you can see that how much is your geometry extended in X, how much is extended in Y. Okay, and then you can check your mesh quality from here as well. Display, if you click on it, then you can see there are inlet, there are outlet, there are wall, there are inlet. If you want to individually display it, you can click on inlet, then display, you can see inlet. Click on outlet, you can see outlet. Click on wall, you click on wall. The interior fluid domain. Okay, you can see from here. Then units, if you want to change, suppose you want to change the temperature unit, temperature to by default it is in Kelvin, PQRST. By default it is in, by this temperature you can change from Kelvin to degree centigrade, whatever, say suppose. Then click C, then close. Okay, then if your simulation is steady state, then let it be steady, otherwise it transient, click on transient. Okay, so first we'll going to the steady state simulation only. If your space is planar or axisymmetric means you can see that, you can say that if suppose this is your domain which is symmetric about any line. Okay, which is symmetric about any line, you know that this is your domain and this is symmetric about this line. So in that case what you do, you only create the half of it, and then by default you define an axis. So whatever is happening over here, the same you can imagine, you can visualize in the other part as well. That is called axisymmetric. Axisymmetric is symmetric about any axis. Okay, in that case we could have done that also, but we did not do this, but let it be there. We can see other things later on. if you want to check the gravity effect, you can mention the gravity value. See, by default, this axis, where this axis, where are the axis? Okay, I can't see the axis. Okay, so we created the geometry in the xy plane. It's a 2D, so we have to give minus 9.81 y minus, because it's a positive, it's in negative y direction. Okay, if I want to take care of this, okay, then let it be, let it close for the time being. Then we can go to model. If you want to use, there are multiple things. Multi-phase, if you want to use multi-phase model, like so, liquid, water, gas together. Then energy, if you are using temperature thermal effect, you can click on it and you can give energy equation. Okay, if you turn on energy equation, then it will be like this. Click on this, that's it. If you are using any turbulence model, then you can select here, let it be there for, let it be for laminar model. Okay, then radiation effect, heat exchanger, species, discrete phase, solidification, melting, acoustic, so many things are there. Okay, so for the beginning, that much is fine, I guess. From material, you can define the material as well. If you double click on it, you can see fluid is air, aluminum is solid. If you want to use a new fluid, suppose water, you can click on create, click on create. Then name, then in the Fluent database, you can select the water, click w, you can see water liquid. Then you can click copy and close. You can see the water liquid is here. So it's a property of water, it's a property of air. If you want to change any property of liquid and air, you can change from it. Density is this much, cp is this much, viscosity, and whatever things, so many things are there. Then motion definition, we don't need to bother about. Cell zone, in cell zone you can see there is a fluid, and in cell zone I can see only one fluid domain. If you see here, only one cell domain, cell zone condition. If you click on it, you can see cell zone. So it is, by default it is fluid. If you want to make it solid, you can make it solid as well. By default, let it be for fluid, make it water. Okay, there are so many things we can do with this as well. We can give a source term, we can move the frame as well, but don't need to bother at this moment. So you can, if you selected this is as a water liquid. Okay, then apply, close. Then let's, coming to boundary condition. This is inlet. If you double click on it, you can see the boundary condition open like this. Just click on it, group by zone type. You can see inlet, outlet, wall, internal inlet. So you see, we want the velocity inlet. So by default it is velocity inlet, but if you want to get mass flow inlet or pressure inlet, velocity inlet means you want to give the velocity inlet. Mass flow inlet means mass flow inlet. You want to specify the mass flow rate. So go to edit. You can see the velocity is asking for. It is asking for normal to boundary. Make it normal to boundary. Okay. Suppose in this case our velocity is 20 meter per second. It's a very huge velocity. 5 meter per second. Okay. You can give some expression. You can give your user defined profile. If you want your velocity to be parabolic, parabolic profile means at the inlet you have a parabolic profile. You can give UDF profile expression as well. Let it be constant for this moment. Click on apply, close. At outlet, you should have the, by default in any fluid flow problem, if you have an outlet, it is by default set to pressure outlet. That pressure outlet is set to be zero gauge. That means release to atmosphere. Zero gauge pressure means releasing to atmosphere, normal to boundary. Click on apply, close. Walls, I'm not giving any kind of condition here, but I can give what I can give. I can give the temperature condition. I can give, see, if you click on it, walls, then click edit, you can see momentum option is there. And see, you see zone type, zone name is wall. Adjacent, what is just beside it, it's a fluid domain. In thermal, you can give heat flux, you can give temperature, you can give convection, radiation, mix, system coupling. So I am giving it to be a 75-degree wall temperature. Okay, that means the wall is at the temperature 75 degree. Okay, yes. Okay, So now coming to we don't need to use anything by default. Let the methods to be by default whatever it is. Controls, let it be the report definition. Okay, no need to use it. Go to monitor. Now residuals, click on it, residual. You can see there are residuals of continuity, x velocity, y velocity, energy. So whenever in CFD any simulation is running, we have some errors, or we have two errors that needs to be minimized, and that we can uh, see from this residual. Okay, what are the residual, what type, what it looks like, we'll see later on in this while in running the simulation. But by default we have to give a convergence criteria. In this case the convergence criteria for continuity is 0.10 to the power minus 3. Here it is 10 to the power minus 3 to minus 3, and for energy 10 to the power minus 6. You can change it by yourself from here as well. There's no thing. If you don't want to check for convergence, you can uncheck it. Okay, we can uncheck it as well. What happens that if every residual goes to this level, the solution will stop by default. Okay, we'll see that. Okay. Okay, report file. If you click on report file, you have to click on new, then this window will open up. You have to give the name to this. Suppose I want to let's first create some lines, okay, in our system. Then it will be good to understand this one. Go to general, go to display, then new surface. I can create point, line. Why cannot I create a plane? Because it's a plane. It's still by default it's a 2D. So we can create some line. We can give a name over here to the line. L1, suppose, name whatever you can give. So by default we should know what is our origin. Our origin is at this place. So if I want to make this line over somewhere at this place, I have to give coordinate. For any line, two coordinates are needed. Suppose x value is 0.05. It's in meter, remember, it's in meter. And 0, and then next line is at 0.5, and the next is this one is what, 0.02. Okay, 20 mm. Okay, now then create. Okay, now this one is created. I don't want to see this interior fluid domain. Close it, make it L1. I can visualize. Okay, so this kind of line, some bad coordinates I have given, that's why. Okay, I have given 0.05 and 0.5, that is why it is. So I don't want this. I want line 1. I'm giving it a new name again. I'm giving it a name, change it to be this one. Create, close. If I select the line 1 display, you can see the line. Okay, but I don't want this line. I can delete this line also. Yes, ANSYS new version, I have to look for from where to delete, but let it be. And now if I want to create a new line again, now this time I'm giving the coordinate 0.5. 0.5 is very far, I guess. 0.075. Y coordinate is 0. 0.075. This one is 0.02. Now this is line number 2. Okay, just some random. These are the monitor points that you have to look while doing. You have to make while doing the simulations. Click create, and line number 2 display. You can see that one more line is created. Okay, I don't want this line. So what I can do, I can delete these lines from somewhere. Create a line. We can also create from here also. See results, we create, manage, I guess from manage. Yes, from manage I can L1, go to this results, then manage, go to click L1 and delete it. Okay, now you see that in display, you will not see this one. Again click on this, see. Okay, now going to this report files, double click on it, click on new, then just name it. Suppose I want to see the temperature, because I've given the temperature to the walls, so I'm giving T1. T1 name, temperature, whatever name you want to give. Temp1, temp1 line. Okay, okay. So name, if you want to create an output file, if you want your file, your data to be saved, okay, then you can name it as temp1 line dot xlsx. Excel file will be created. Okay. Uh, then since it is a steady state simulation, so we want our data to be obtained at every iteration. If I would have selected the transient, then it will be transient, sorry, time step or flow time, that we'll see later on. Okay, then okay, then new, then area weighted average, this will open. Again give it a line, temp1 line. Okay, area weighted average, I want the field variable is our temperature. I want static temperature at line 1. Okay, then click OK. You will see the temp line 1 is created over here. Now OK. You can see the temp line. Now I also want to see the same thing on temperature on the line 2 as well. So once you click, you don't need to change the name over here. You can uh, click on this area weighted average. You can name it as temp line, temp2 line, temp2 line. Now you have to select temperature. So also if you want to select, see the velocity at this line, you can select the velocity and you can select the line 2, and also make sure that this report file, if you want to report this file, you can see this is checked, report plot. This report plot will be displayed over this console in this graphic window. This is called, this section is called console, this is called graphics. So this report plot will be shown in the report plot. Print to console, that means its value will be printed in this console window. I'll show you how it will look like. Okay, then click on okay. Now if you want to report the same file, the data of velocity in the same Excel file, you can click on this, then okay. Okay, now but you can also change this name from here. You can see temp to line dot xlsx. By default it is dot out, that is no issue. You can change the name in your targeted folder as well. Now click ok, close. Now you can see that in report plot also there are two type of plot are coming. Can you see? Well, you can click over here, you can click on it. In report plot you can see this one. Now if you click ok, if you just double click on this one, click on this, click on edit, you can see this one. Okay, since these are the two different variables, but suppose for example I want to check the temperature at the second line as well. What I have to do, I have to click this one, click on new area weighted average. Suppose I have given the wrong name. Okay, so I should have given this name as velocity, VEL. I've selected the VEL. To for that, just click on it, click on edit, change the name over here, VEL, click OK. See the name is changed to this one. Okay, this VEL. Here I have to change the name as well. Okay, I have to change the name here also, VEL. So many changes you have to make. Velocity dot vel to dot xlsx. Okay, so you can see. Okay, close. If you want, if you also want to check the temperature at the line 2 also, click new area weighted average, give temp to line temperature. Okay, line number 2. If you want to see the on this in the same graph, you can click on temp line 1, then both the temperature will be shown in the single graph. import plot, print to console, okay, okay, close. So many things have been done. Let it be for the first video. Then we have to do nothing. Go to initialize. There are two methods of initialization. Let it be for standard initialization. Compute from it asks for, you can select any inlet outlet, whatever you want to select. Just click on inlet. If you select outlet, there will be no issue. Inlet velocity is 5. Even if you give it 5 or 6, does not matter. Temperature, inlet, yeah, this is important because inlet, see, this is actually okay, I have given inlet temperature to be 75. If you initialize the solution with this temperature, there is no issue because boundary condition I have given it to be what I missed it, that in boundary condition, if you go to inlet, you can also change the temperature also. Momentum I have changed. I can also change the temperature also. I can change this temperature to be 30 degree or this 20 degree. Apply, close. So that I mean to say that if you in the initialize panel, if you even if the inlet temperature is 20, if I select inlet, it is by default 20. If I make it 21, there will be 25, there will be no issue. Initialize it. Okay, there are multiple options that are of different use. Okay, okay, so this method is set to it is saying that it's saying pressure velocity coupling scheme is set to simple. It's set to coupled. You can select the simple. There's no problem. Okay. See, it matters. I'm not saying it does not matter. It matters, but depends upon what type of simulation we are doing. And right now we are doing the basic simulation. Now in the calculation activities, if you want to save your simulation file after some iterations, you can select. You can click here. You can click. I want to save my simulation after each 20 iteration. Then you can give it a very. This is important when you are doing transient simulation. Okay, and click OK. Then you can click on run simulation. It is asking for number of iteration. I can give whatever number of iteration I want. Okay, I can give whatever number of simulation I want. Iteration I can give 1000. See, it does not matter. You give 1000, you can give 1 lakh, does not matter. But don't give like 10. Okay, suppose I give it a 10. Okay, click calculate. Calculation complete. Oh my god, calculation complete. No, calculation is completed because I given 10 number of iterations. If I would have given it 1000, 10,000, I'm not sure at which iteration my solution will complete. So give it 1 lakh, does not matter. Okay, scale, see, this is what I was talking about, the scale residuals. Okay, this is what I was talking about. So you can see the temperature plot, the T1, T2 are plotted at the same plot. Okay, the temp 2 line is here. Velocity, I guess I've made some mistake. That is fine. I'll see later on. Mesh, you can see here. Okay, now if I click on calculate, click OK. Now it is running. It is running, and this should go down. Okay, this is trying to go down. You can see here. Let me stop this. You can see print to console means that these values are being printed over here. Okay, temperature line 2 पे इतना है, and then temp 1 line I have not selected, I guess. Okay, okay, let's run the simulation.